Hi guys, Graham here again, your automotive and battery specialist at Bainbridge Technology, your leaders in power products. I just want to follow up this video today from my video last week talking about some of the changes in the new batteries and the way they look and slightly different. Just want to go a little bit more in depth into the batteries and the changes and the reasons why we did change them. So first of all, I'd just like to touch base on the SP range, all our standard battery, standard power in our conventional style case batteries, because they are slightly different to the Slimlines, because obviously they have Anderson plug terminals. So as you would have noticed, we had the screw-on style of terminals previously, and the models that had the DC to DC and had the small screw-on terminal and then the larger screw-on terminal. So we have noticed that there must have been a few he-men out there. Someone's been eating their Weetie Bix because we did have some units where they were just so over-tightened that they actually broke them off internally or twisted the brass internally as well. And with, especially in some caravans, you'll find that they'll just pile and pile and pile a heap of ring terminals on top of each other, and it's not the best connection. So we've actually gone to these solid brass terminals inside, which are actually basically go onto a big solid BusBar plate internally, and they just make such a better connection and alleviate a lot of resistance and voltage drops and so forth, and make it a lot easier because you literally can just put your loads or whatever you're going to connect it to here going to a BusBar or going to a distribution panel and bolt them on, and then you're actually tightening the bolt up with either a spring terminal or a spring washer, so forth, and can clamp it right up tight and until your heart's content, and it's not actually twisting or torquing anything inside. We've then also put these little pieces of acrylic around them, which obviously display positive and negative, but also just to stop you from, tapping down with a spanner or doing anything and shorting on the on the case. So that's the main reason we've changed these terminals. It also gives us a lot better bite on the BusBar inside to terminate the actual BMS and so forth. And that's one of the other things that's changed right across the board. The BMS in all the batteries is the same for the standard 100 amp continuous, and then the 200 is different again. But the standard 100 amp, you'll notice that we've taken all the fuses externally off of the cases. It now is built into the BMS internally. It's a resettable 100 amp resettable fuse. So to reset it, you would need to disengage the battery, take the terminal, disengage it, and then it will reset. So it's best to do that. Now, you can do that one of two ways. You can either just take it off of here, or if you're having one main output to go to a distribution panel or a box or something like that, you can quite easily just put, say, a 100 amp circuit breaker in there and manually set one, so that you can just push the button, open that connection, and then put it back together. If you have any sort of fuse on there, they can still draw like a couple of milliamps or whatever, which is still enough for that fuse to not disengage and reset itself. So it has to be completely disengaged from the battery. So as I said, the resettable circuit breaker, reusable circuit breaker, manually adjusted, probably the way to go, or an isolation switch, whichever way you want to do it. So that's an awesome upgrade that we've done for that. Makes the batteries look a lot neater and cleaner, and a bit of peace of mind to know that it is a resettable fuse all inside there. And so if something does happen to short or someone does something untoward, it's not going to do any internal damage to your components and your battery and also your vehicle. So that explains that side of it. So give me a couple of minutes and I'll just reset up, and then I'll go through some of the changes for the Slimline batteries with the DC to DC built in and the extra upgrades that we've done to those. Hi guys, back again. Now we'll just like to explain about the DC to DC setup, especially with our most popular battery, which is the 110 Slim. So this will be for all models, the 75 Slim, the 110 Slim, and any of our standard range batteries that have the DC to DC, and they now have the same DC to DC setup in all of them. which is fantastic. So once again, the BMS in these batteries are the same as the battery I was just explaining to you about. It now has an internal fuse, a resettable fuse. So there's no need to have to run an external fuse on these. Look, by all means you can do as an extra piece of good practice to cover you for everything that's plugged in out here, and to isolate any cables if they are a bit of distance between here and your appliances or your loads. So you can put an external fuse on there if you want, but the one is on the battery. Once again, if something does happen, you'll notice, because the BMS will shut down, there'll be no output, and the battery will basically say 0. So you will have to disengage your grey Anderson plug or switch an isolator off, whichever way you go, and then reconnect it for it to fire the resettable fuse back up again. So on the 150s, our previous model 150, on the end here, you'd have noticed that it had the 2 little poles coming out, and it had the 100 amp mega fuse on the end, and that has now been removed and now internal. So I have had some people go, oh, I think you've sent me the wrong battery. It doesn't have the little lugs on the end like the one on your photo. That's now been upgraded, and you'll notice that it is internal, and so therefore then you do not have that external fuse on the end. So one thing you will notice is the first bit of difference is the VSR setup down here. It used to just be a single little trim pot with a green light. You'll notice it now has 2 trim pots. Out of the factory from us, you'll notice that the bottom trim pot will be on position 4 and the top trim pot will be on 0. Now, this bottom trim pot is the voltage settings. So there's position 1 to 6 is all different voltage ranges. And if you scan on this and in the box, you'll notice, and you'll actually get a printout and it'll tell you what the different voltages are. I can tell you that voltage at position number 4 out of the factory means that if you're connecting it up via voltage sensing, it will turn on at 13.5 and above, and disengage at 12.5 and below. So for about 90–95% of the vehicles, that's all you need. That's perfect. Now, to show you that, you'll notice if you look down here, there's no green light on at the moment. As soon as I turn this up and go to above 13.5, you'll notice that the little green light's on, telling you that the charger is now engaged. It's not actually pulling anything in from here at the moment, because this battery is 100% full. It was 13.5 to start off at. So obviously, if the loads were down, it would be pulling. So in the last 90, well, the last 10% of its charge, the BMS actually regulates the amount of charge and starts decreasing. So as the voltage goes up, the current goes down. So so it does turn it off, so you're not trying to whack 20 amps into the battery right until it's 100% full. So yeah, so that explains that side of things. Now, if you wanted to, if your vehicle was working on a slightly lower and it doesn't get to 13.5, some of the Toyotas only really sometimes they only go to 13.3, 13.4. You may want to turn it down. So that bottom dial, you would turn down to position 3, which means it would then turn on and engage at 13.2 and above, and disengage at 12.5. But as this one's on position 4 at the moment, as we said, if I turn this down now to 12.5 by 4, you'll notice that the green light has gone off once it falls below that mark. So yeah, so once it gets above it, it turns on, and then once it gets below it, it turns off. So that's exactly how the VSR works. Though in some vehicles with your variable control or variable output control alternators, smart alternators, whatever you want to call them, basically it regulates the output depending upon the status of the starter battery of the vehicle. So therefore then sometimes those voltages are above or below. Now in the cases of Nissans, Volkswagens, the current model 221 Ford Ranger, they won't work with any of those tolerances. Like I've got the new Nissan, and when I start the car up, goes to 14.1 volts, 14.2 sometimes. So therefore then it would turn the battery on and the charger on in the battery, not a problem at all. But after about 15 minutes of driving, it drops down to 11.8 to 11.9. So it's well below that reading. So therefore then I could say, oh yeah, we'll just turn it down to position 2, for instance, so it turns on at a lower reading. But the problem with that is it's always then going to be pulling a fair bit of chunk of power out of my battery, even when my ignition's turned off, because your starter battery generally would be around 12.4, 12.5, sometimes 12.6 after it's full. So therefore then you actually are keep taking power out of that to do so. So to do that, you do the ignition override setup. Now I'll just set this up here in a sec, and I'll get back to you to do on that one. So what we do effectively is now we go to the top dial. So actually I'll talk to you about the top dial. The top dial is a timer delay. So effectively it's out of the factory, it's on 0. That means that basically as soon as it gets to that lower reading, like I said, this one disengages 12.5. If you know that your alternators may drop down to around that sort of figure for 30 seconds, a minute at a time, whatever like that, you can turn this timer delay on. So therefore then it would have to be there at whatever specific time that you've set. So position 1's like 30 seconds, then it goes to a minute and a couple of minutes and 3 minutes and 4 minutes and so forth before it would actually take over. So if that means then, say at 12.5, this is still on, and you don't want it to turn off, you can actually turn that timer delay, say around to 2 minutes, for instance. So it would have to be at that position for 2 minutes or more before it would turn off. But as I say, simply just having that on 0 is probably the safest and easiest way to go for the initial setup, and it's set on position 4. Now, if we want to do, like I said before, say in a current new model Nissan, where you need to have that ignition feed, and to be honest, most vehicles with a smart alternator, I would just say go straight to the ignition feed setup. And this is how easy it is. You literally get the top dial and turn it from position 0 all the way around, because it clicks, all the way around to position 6. That now means it's overriding the voltage sensing relay. You don't have to change that position 4 or whatever it was on or whatever. You literally turn that to position 6. The only way this turns on and off now is by receiving a 12 volt power supply once the ignition's been turned on in the car. So obviously it means that you'll be running and starting the car. So the battery, when the car's running, the charger will be on. When the car's off, the charger will turn off. Simply as that. So you'll notice here that I've got this, I'll just turn this up to say around 13.5 volts, and I will simply plug this in to this little red here. Now it's a banana plug, by the way, too, so similar, same sort of plug that you have on your the leads that come with your multimeters, but you can buy these banana plugs quite easily from places like Jaycar and a lot of your electrical wholesalers. So that one there I will plug into there. Now it takes about 15 to 20 seconds or so, and then you'll notice this little green light will come on. The reason it takes that long is it's a soft start setup for the BMS and the DC to DC. We don't just want to go turning it on bang straight away and then it's supplying that current and that load straight away, because this is literally just turning the relay on internally, which then obviously closes the relay, completes the circuit, so it allows that power to go through that you've got plugged in from your car. So you'll notice now that green light is on. So while I've been talking there, the green light's coming on. So if I simply disengage this wire, which is the same as turning your ignition off. So yes, you'll notice that by pulling that out, it's the same as turning ignition off, it's turned off. Put it back in, start the car up again. As I said, after about 20 seconds, it will turn back on and replicate the same as if you were turning your ignition on and off. That way then you've got a fail-safe way that you know that the DC to DC is not going to keep pulling power from your cranking battery and leave your cranking battery flat, and it will work the whole time the ignition's on, regardless of what voltage is coming out of your charger. So as you can see, that green light's on already. So that's it. That's simply how easy it is. Ignition feed, position 6 on the first dial, and you have that ignition override set up. Nice and easy and simple, and that's the same applicable for all batteries. So if you need any more information, please don't hesitate to give me a call. My information will be below on the email. Yeah, until next time, bye for now.